So we're NewSpace NYC. We are mostly a community and becoming an incubator for space startups. We do events mostly weekly, with bigger events quarterly. And we had one of our bigger events, the Space Sharks, about maybe a month ago now. And it was a pitch contest where different startups would come and pitch their ideas. And we had 2 rounds of that. Adam was the winner of that event for Ursa Space. So he got 1 hour with some of the...
Thanks.
1 hour with some of the investor judges, and also got into what we're calling an incubator beta with NewSpace NYC. So we've been helping them with some marketing stuff.
Yep.
And yeah, so with that, I'll let Adam take over.
Okay, cool. If you guys don't mind, I'll sit here unless you guys want me to stand. You guys can all see. I'll try to actually, I set up this conversation to be a little bit more of a conversation necessarily than that's just talking to you guys. So I have a lot of things I want to hear your guys' feedback with. So the first thing, so I'm actually the founder of Ursa Space Systems, and the talk that I wanted to give to you guys today, not 100% about Ursa Space Systems, but what I want to do is talk about this idea of new space versus traditional aerospace. I think a lot of people talk about it, but there's one very particular part of it I wanted to focus on, and it's pretty important to me, is the art of systems engineering. And we'll get through this a little bit, but this is really based on a paper that NASA actually did in 2009. So it's called the Art and Science of Systems Engineering, and right there's the link to it if you wanted to go download it and read this paper. But yeah, first of all, let's just start off with a little bit about my background, so as you guys can see where I came up with this idea, and we'll go from there. So I went to Cornell University back in 2006, almost 10 years ago. It's pretty, it's hard to believe. And while I was at Cornell University, I actually worked on a satellite called a CUSat. There's a university nanosat program. Really, that was really the first step into the space industry. And how do you actually do something on a very low budget? How do you get something going in a college team? From there, I actually stepped into a company called Space Systems Loral. They're out in California. And there, I was lucky to actually be the lead systems engineer on two satellites right out of school. So the first one, down here in the lower left-hand corner, was the Protostar 1. And that was actually taking a satellite out of storage and getting it ready for launch. The second one, that was when I was at launch base with Viasat 1. So we took, for those 2 satellites, actually went all the way from, how do we get this thing going, to the launch base. And, SSL, is a traditional commercial aerospace company. Then I got this cool opportunity. I actually moved into a new business development role for a couple of years. So this lower satellite, this is one of my first big wins when I was in new business development, was Jupiter 2. That was for HNS/EchoStar. And then, moving from the geocomms, I actually started to work into a bunch of NASA projects. So that was the asteroid retrieval mission. That was a pretty fun mission, looking at how to use electric propulsion, large solar arrays to go actually reach out, capture an asteroid, bring it back. What are all the things required in that? Then moved on, after doing that for 8 years, actually decided to let's jump and start my own company. And so you can see here, so that's Ursa Space, and I should show you here, it's quite a change. I went from 3,000 person company to now we're 5 people plus our little baby, plus my little baby that just was born a couple months ago, and yeah. So so it's really awesome, going from that big team down to a really small team, and there's a lot of things that I had to learn of what's the difference and how do you change to accommodate that. Let's start with some definitions. So I'd love to hear around the room. I did this actually before at my last company. What's the definition of new space? I think there's about 20 different definitions, so I'd just like to hear, anybody have a definition they want to throw out? you guys are called NewSpace New York City. So what's your definition?
Yeah, so I would say that NewSpace is basically this new breed of companies. So you think Aerospace, and you think APL, you think Lockheed, you think Boeing, and they're the ones that get a lot of stuff that we see with NASA done traditionally.
Mm-hmm.
But now we're seeing a lot more private contracting happening.
Yeah.
So basically, you could describe it as this trend towards the privatization of space with younger startups that aren't these huge military contractors.
Okay. Anybody else want to throw a definition in? That's a pretty good one.
I'll throw one.
Yeah, go for it.
I think new space is epitomized by SpaceX, and what that means to me is that they are taking new and innovative approaches to existing problems and solving them at much less cost and much smarter ways. And I think they're dragging the rest of the old space industry kicking and screaming into the next century.
Okay. Thought I saw one more hand here. Go for it.
Yeah, I agree with all these definitions. I think another interpretation is kind of a couple of different Moore's laws. One being the cost of launching stuff into space just dropping a lot, and of course that you can get much more interesting stuff, cheap sensors and electronic stuff for a lot, and that's just a lot less weight because you can get more transistors on the chip and so forth. So I think the combination of those two trends, lowering price per kilogram and more floating point operations per kilogram together with maybe some cheap sensors, giving a lot of opportunities for private companies to innovate novel technologies and business solutions, kind of like Ursa Space.
Cool. Yeah, so I think you guys got pretty close to what my argument I'm gonna do today. So, and I agree. When I did this before with a large company, there was a whole bunch of different answers. Was it Moore's law? Was it getting cheaper? Was it originally some of the definitions were very launch focused. It was reducing the cost of launch and getting private individuals into space. Such as X-Corps, and those folks really were the poster child for that. But I think you're all right. It just really refers to this community of space companies that are not necessarily the big folks. And actually, it's funny. Actually, in the '80s, it used to be called Alt Space. Was the name before NewSpace. So this isn't necessarily a new movement. I think this is something that's been growing for 20 years. Of course, we have to go to traditional aerospace. Traditional aerospace, I think a lot of folks, with the definition you gave for NewSpace, already define this. These are you think of the Boeings, the Lockheeds, even sometimes NASA, not all the time. These are the folks they're the incumbents, they're the large players, and a lot of their because one of the definitions was they were very dependent on government funding in order to move forward versus commercial funding. So there's a bit of that. So one thing that was always interesting was I always tried to figure out where do you categorize commercial communication satellites? Because if you look at versus a government military satellite, those are very expensive, very complicated, of course, definition of traditional aerospace. But sometimes I look at a lot of the commercial communication satellites, and they've had a lot of the same cost and budget pressures as any commercial company would have. And so I don't know, what do you guys think? Do you guys think that they're more new space, more traditional aerospace? Where do you think they land?
I would say mature commercial space. So they've been around for a couple of, they've been separated largely from government contracts, so they've been independent, so they have quite a bit of business to business, right?
Yeah.
Revenue streams.
Mm-hmm.
So they do stand a little, the traditional communication satellite companies do sort of occupy their own kind of, niche or reality in terms of, the general commercialization of space.
Cool. Anybody else have an opinion on commercial comm satellites?
I would say that they are agnostic to new or old space. They just want cheaper cost, more reliability, and so I think they are going to benefit from NewSpace.
And I agree with that. That's, I worked for a commercial communication satellite company, and we were always wondering, why, NewSpace, some of the definitions were, commercially focused. We're like, well, there's a huge commercially focused communications, segment of the market already. And I think it does a disservice to that industry, ignoring that, they've already been doing a lot of these things that NewSpace is bringing in. But I think there's one important difference, actually, and I think that's culture. And I'll get into that in a second. I think there's a big culture difference between what people are starting to classify as NewSpace versus traditional aerospace. That's a really key factor. So last definition, systems engineering. I think there's a lot of, and systems engineering really means something different to different people. And this is really, I have worked in both traditional NewSpace, been to a lot of the NewSpace companies, and I really think, and even going to software companies, and I really think the definition of systems engineering and the way it's applied across the company is one of the key differences that goes on here. So in general, systems engineering depends on where you go to. So for example, I think if you would go to, a Lockheed type company for most of their projects, not all of them, there's very much a culture of a science of systems engineering. There's a known science of, I have to do a requirements flow down, I have to bring these pieces together. And versus on the other side, there's an art to systems engineering. And I think there's a key, and I honestly feel that that was the key piece that's missing. So let me dive into the systems, the science side. So for systems, go ahead.
Who's missing the art part?
Traditional, what we would in this room probably call traditional aerospace. And I'll talk about that in a second. Just so you guys are clear on my definitions here a little bit, is the first part of systems engineering is systems management, and this is really the science. How do you take these very complex systems and actually turn them into something that's real? Without systems engineering and the science that's developed through the years, we wouldn't have things like the cell phone. If you actually take a step back and look at the system behind a cell phone, that cell phone knows where you are, can give you an optical map of city where you are, knows how to connect into the internet, knows how to find the information you're looking for, and then send it back to you. And that all happens, and Google has it to where they even try to predict what you're going to do.
And you can also make a phone call on it too.
You can make a phone call on that thing. I know, but there's just, but it's such a complex piece. Go ahead.
But I wouldn't call that a cell phone. I would say the cell phone is a piece
Agreed.
of this beast we
Yeah.
all carry around.
Yes.
So we may all call it a cell phone, but
Mhm.
it's much more than that. The cellular and the telephonic
Yep.
aspects are just two of the pieces of
Mhm.
what it brings.
Yeah. So, and I totally agree with that. I simplified the cell phone, but and then we look at the space side, and especially on the space, we start looking at missions that we want to do, going back to the moon, going to mine from an asteroid. These are not simple problems to go through, and and having a piece go wrong. So if you look back at, I'm going to kind of use Apollo 13 and the International Space Station throughout here. So if we look at the Apollo 13, they had a failure because there was a requirement that was missed very far back, and it took them a while to trace it back to what was that actual failure. And so the science is important to be able to have that trace of this piece was manufactured, because actually what happened was there's a voltage mismatch in a system because a requirement and a drawing got changed. So the science is actually a very important piece, especially when we try to do more and more complicated missions to space. We try to go to Mars, we go to the moon again. The other side of it is the art. And so what I define the art as is technical leadership. So the technical leadership, this is that ability and that person who can go out to the team and has that gut feel that knows, okay, we've done enough, or this is kind of the way the architecture should go, and we're going to make it happen. So now, really, in the paper that I'm referring to here, their theory was that, before the 1980s, technical leadership was really the heart of systems engineering. So this is during a lot of the Apollo work, a lot of the early space work. You look at early communication satellites, it's a bunch of guys without any clean room suits on taking these satellites. They set them outside to test them. There's none of this clean room piece that's going on. But then in the late 1980s, my feeling is that, and also this paper's feeling, is that many aerospace-related government and industry organizations really moved away from that hardcore technical leadership culture, that art, and really moved to one of systems management and the science. And so this is where you start having, and you'll see as you go through, if you move yourself away from that art, you move just to that science, and you're really reliant on that process. How well do you know your system? How well do you know what you're doing? Can you make those judgments of, is this good enough, not good enough, and build that culture. So, do you guys have any questions up to here? Yeah.
This is a quote, though?
This is a
direct
quote
from the...
This is a direct quote from that paper.
See, I would just say, instead of science, I would call that engineering.
Yeah.
Because engineering is, I think, inherently judgment-based, whereas science is there's physical laws and...
Okay, so maybe I disagree with a little bit there. So really with the science, when I refer to science, this is really the rigor of, so engineering, any sort of engineering is really some sort of mixture of creative process and some sort of rigorous process so as to be able to come up with the science.
Founded
Exactly.
in physical principles, of course.
So you're talking more about management then? It's a style of management or the science of managing systems engineering for large satellites?
It can be large, it could be small. It's just really how do you manage that system? Because anytime we're talking about a satellite or we're talking about a computer, these are collections of many individual types of system or many individual components that you have to have interfaces and definitions so that the whole system comes together and works. And there's definitely a difference in culture in whether you're a very science-oriented culture. I don't know if any of you guys have worked at a large traditional aerospace company, and everything has to be, there's a very strict process of requirements, flow down of information that you have to go through. Versus the interesting thing is now when you go to a startup, you only have 4 people. You don't have time or the ability to create all that paperwork to show where all those pieces go. So the concepts of how to do it, but you just have time. So let me go on to the next slide. So this, I think, will help explain it. So now if we go to a very traditional group, my frustration, and actually one of my co-founders' frustration with the traditional systems was it was process without understanding. There was we had a process. Here's the requirements flow down, and we had heritage. But heritage is sometimes a good word, sometimes a bad word. It means it worked, but as long as the same conditions were met before, when you had it. So how much is heritage actually worth when you've changed 20 or 30% of it? Did you change the critical part of that design for heritage? The second piece about it is requirements are very easy to add, but I don't know how many of you have tried to remove a requirement from any of these systems. It's very difficult. And actually one of the really hard things was, the hardest thing about it was half the time I did not know or could not figure out where a particular requirement came from. And a lot of times, once we did find out, there was a failure 15, 20 years ago that this requirement was mandated to be put in, but the actual assumptions behind that requirement were, didn't exist anymore. But if you live in this very science-oriented, you just follow these steps. It's hard to find where those assumptions have disappeared and they're not useful anymore. The other part about it, yeah, go for it.
I can interject it. That actually is the opposite of science. If you can't go back to your fundamental reasons for why a requirement is there, then you're not scientific. You're just doing things because that's the way we've always done it, and that's clearly not science.
That's great.
So, but going back, this is actually what adds to the cost, which is what the old space industry has to do, which is why it's so expensive, is they have all these rigorous procedures that result in as guaranteeable result, which is a positive thing, as you can, but that costs lots of money. To do it as a startup, you throw out all that, and you sort of fly by the seat of your pants.
Yeah. So, but it's interesting too. There's another thing that happens with this is, just because of this, you become very far removed a lot of times from your customers and your suppliers. And so, I think that is what causes the cost growth and the very large pieces to happen with this, is because what happens if I haven't talked to my customers, so I don't really realize that they don't need this extra margin, or I don't realize that they didn't need this additional feature for their particular mission. Or on the other side of it, it's interesting when you get stuck in these large processes, you don't also talk to your suppliers and don't realize that they could do something to remedy this problem that you're going through all these steps to work through. And really this is just my experience, not every place is like this, but when I was in the larger organizations, it was a lot of work to really understand your customer, understand your supplier, and not get lost in that process, and not, it was very tempting to just follow the process because you don't have to necessarily think. Hence, that's why I put the minions on the bottom of the slide. Just really, yeah, go for it.
I was just reading yesterday about a thing called the process communication model, which was developed by a man called Carl and used by McGuire at Master. You know about that?
No, I haven't seen that one yet. I'll have to read that one.
I should post a link to it in the Meetup group.
Okay, that'd be great. So the opposite is the startup. This is, the way my experience has been so far, there's no process, because you can't take the process you left with. You can take what's in your head, but not everything. There's no process, and there's only partial understanding. Yeah, it's really what a startup is. So I put the little minion with the bananas because really when you first start a startup, you're like, it feels so liberating. You're starting from scratch. You just kind of go nuts. You're like, this is so enthusiastic. This is great. I'm not stuck. I can go do this grand mission. Then the other really great thing is you're really close to your customers. You get that opportunity to go communicate with the customers, communicate with the suppliers. And it's really great because you actually start to see the connection of how does this customer requirement link to where a supplier could be versus what I could do. But then you start being like Gru was when I don't know if you guys have seen the movie there, but basically Gru from Despicable Me, he wanted to go to the moon when he was a little kid. And so you start realizing after a little while in this startup, that process had a lot of corporate knowledge embedded in it. There's also, you don't have all the folks, and you don't have this easily accessible, diverse expert base. And then the last thing is you don't know better. And it's just, and actually going through starting my own company, I think there's a few points where I've hit this point where, kind of like Gru, I have a box over my head, ready to go to the moon, but very depressed because you're like, okay, this is hard. There's a lot to learn. There's a lot I don't know. There's a lot of things I did not expect. And, how do you get through that? So that's a startup. So it's really interesting because now, I think when you look at this, you can see both sides of it. The traditional aerospace, they have lots of process, but you can get lost. But then again, on this, the NewSpace side, which we associate with a lot of startups, there's a lot of stuff you just don't. There's a lot of things that you don't know and you can't move through without that support. So now this is interesting. I've been watching, so now if we watch the growth of what's actually happened with some of these companies. So I chose this here because of Robbie, who's the founder of, one of the founders of Planet Labs. So Robbie actually started working at NASA. So on the left-hand side is Landsat. And so I think a lot of us can agree a Landsat would probably fit in that definition of traditional aerospace. There's a lot of requirements behind, there's probably a table full of requirements behind that particular system. There's a lot of rigor, a lot of structure that NASA and the contractor went through. So it's interesting because Robbie actually led a group in NASA Ames and said, can we go all the way to the other extreme? Can I just take a phone and launch it into space? And so he went and they actually did that at NASA Ames. It worked okay. Didn't last very long, but it worked for a couple days. Which was it was interesting because he saw, hey, we could just take something and make it happen, and it didn't necessarily have to be the I don't know how many hundreds of millions they spent on Landsat. So now let's fast forward about 5 years. So it's really interesting watching how Planet Labs has started to evolve from this company that started with a cell phone satellite, and now they've actually evolved to the Doves. Doves are still incredibly cheap. So if you look at a scale of Landsat versus a Dove, they're very, they're quite a bit more cost effective. And it's really interesting going to Planet Labs and seeing their culture of how they think about the world. They question all those. And the biggest thing I see when I go to visit them from a culture is they questioned all these traditional thoughts about how do you build spacecraft, how do you have to test, how do you have to go into space. And it's been really interesting watching them learn. And they definitely have learned a lot of things that had to be improved in order to have a level of reliability in space. But if you look at where they landed versus what they're competing against, it's quite a step forward. And really, what I saw here was really, this was just really a culture change. It wasn't necessarily that they were, different engineer, trained differently. They weren't necessarily, and I think we had a discussion, they weren't necessarily more risk tolerant. In fact, if you look at it, they've created a system where they can have a launch failure, they can have a satellite failure, and still get, data that they need from it because they're looking at a system solution versus necessarily a single satellite. So it's really interesting because if you look across this, you really see how a culture of that technical leadership really took something that was really expensive and has started to, is starting to compete with it. I would not say the Planet Labs Doves are necessarily fully competing with the Landsat yet, but they're getting, they're doing well. I think much better than a lot of people would have expected. Do you guys have any questions at this point? Okay. So the next thing here, all right. So this slide, I actually think I could do an entire talk on. And really what I stepped back here is I said, okay, we looked at this culture that has happened, and I think Planet Labs is a really good example of this NewSpace and how the culture evolved. And they started to step back and they say, what are the ideal qualities of a systems engineer that, could really start to balance some of the good of the traditional versus some of these ideas of the the new space world. And it's interesting, we just go around appreciation. So I think it's interesting because actually one of the ones I put up there is appreciation for the process and rigor, but knowing when to stop. I think that's one of the key things. Really, not everything needs to be analyzed. I think once something's been analyzed once, a lot of people can look at it and say, okay, that's going to work. And I've seen some companies have really realized that it's actually cheaper to just fly something than it is to do all the analysis to prove that it's going to work. And so there's interesting questions as a good engineer should really be able to step back and ask those questions and not necessarily blindly follow one culture or the other. Ability to see the big picture, but yet connect to the details. I think this is key. I think One of the things I saw in some of the traditional worlds is you have a lot of very detailed folks. They're extremely talented. They can tell you exactly how to analyze something, how to put something together. But developing somebody who can really see that, who can step back from that, who can converse well with someone who's detailed, but step back and really communicate in that language and say, how do you create that connection from one to the other is important. Comfortable with change, uncertainty, unknowns. I think for a lot of the space industry, being comfortable with uncertainty is hard to swallow, especially with how expensive things are. You know, even a new space company, you know, Planet Labs is starting to spend hundreds of millions. You know, and it's interesting about how do you know, being comfortable with uncertainty, unknowns is something that's, we have to do. And that ability to try and change an organization is really key. Go for it.
I'm sorry, you just said Planet Labs has spent hundreds of millions?
They've raised, what, they've raised
140 something?
Yeah, $140 million.
I mean, they haven't.
They haven't spent it all, but they have raised 140 million. So
Have they released any revenue figures or any profit figures in any way?
I don't know. I'd have to look at that numbers. I wouldn't want to try and quote those. So now, one of the interesting things here was with change. This is actually one of the key things that was the hardest with with a company that was very, like if a company is very traditional, bringing about change is really hard. And actually I think bringing about change even in a new company is hard. I love it. I actually have a quote from Niccolo Machiavelli, sitting on my wall. In The Prince, he actually writes an entire section about how, people who are, even people who are for change are not going to be with you. They're going to be very lukewarm to the idea. So it's something, it's interesting because if you actually look through history, it's a well documented that change is always hard. And that's actually, and something interesting I see too when I've worked with some of the new space communities is, we want to move change, we want to move forward, but it's a difficult, it's a difficult challenge. Even if we are going to improve the lives, those that are benefiting from this, it's really hard because, there's a comfort level with where they are, where their system was. So now a little bit more on the person too. One of the amazing things is I'm an engineer, but I'm starting to learn English class and Toastmasters are really important for engineers, and especially any engineer who wants to be an entrepreneur. Giving presentations, clearly speaking what you're saying, ability to have that conversation is so key. It's been and that's something that's really key to learn here. And I think that's something that I actually suggest to a lot of other engineers who want to become entrepreneurs is, learn, play with that. Go for it.
Don't you think you should outsource it to people who are political like me to do all the talking and say, let's make it happen,
And so and it's interesting, it depends on the culture and who you're talking to. I think if you're, the space culture a lot of times, and this is just my opinion, is very dominated by engineers. Even if you look at the traditional aerospace companies, even if you look at the traditional aerospace companies, a lot of the leaders, the vice presidents, the presidents of a lot of these companies do come from engineering backgrounds. And this actually is a good segue into my other one called what I call a curious T-shaped individual. And really one of the key things I found is taking a step back and looking at yourself and understanding, I'm going to be very deep in knowledge in one area. So if I'm actually a mechanical engineer, so I know I have a pretty deep knowledge there. But what I've gone out, and why I say T-shaped, is I've gone out and I've understood the other areas of this engineering. And it does two things really. The thing that I find useful is having that some knowledge. So for example, I'm now a little bit dangerous with RF, which is good and RF engineering, which is good and bad. But I know how to speak. I know actually how to speak in the language of that engineer I'm talking to. The second thing is having that area of deep expertise. I believe there is some sort of hierarchy that a lot of engineers create on, do you have some technical ability representation? So even if I am talking a business background, if I'm talking to somebody who is, a fellow engineer, I knew very well what I'm doing in mechanical engineering. That gives you a little bit of, I guess, I should have taken more English. I guess that gives you a little bit more credibility and really allows that conversation to move forward. And it's something interesting and subtle that I would say in 10 years, I'd love to redo this and see what my opinions are then, because I've definitely noticed that my opinions on these topics have changed, in just, the last 8 years I've been doing satellites professionally. Team member is interesting, and proper paranoia. I think those are two other ones. I like the word proper paranoia because you really should be, instead of the sky is falling, it should be if the sky falls, this is what you do. This is kind of a key thing. And then the last one was I've been thinking a lot about is being a team member. And this is what I said, that it's very diverse. What we do in space is very diverse. You can't do it with a mechanical engineer. You couldn't do it with an electrical engineer. You couldn't do it without a business person. As much as engineers, I think we like to do it all ourselves. There's non-engineering functions that are important. And so it's really, so really, I think when you leave school and go out in the industry, you just think, it's team member is something they keep emphasizing, but now actually having to lead teams, worked with, led my own company now, it's incredible how important that is and how important all the team members are to put it together. And so the reason I wanted to go through this is really, I wanted to give what is an ideal systems engineer in my head. So did you guys have any questions?
I would just like to make the point to the top box.
Yeah.
The appreciation for process. There is value for going through an SRR, SDR, PDR, CDR.
I agree.
That those steps are there because we've learned from past mistakes.
Mm-hmm.
Now, to your point of knowing when to stop, that becomes a risk-reward issue, balance.
Mm-hmm.
You can cut the process short, maybe save money, maybe get more on the back end, but you are enjoying more risk.
Yep.
So there is that balance, and it's a fine balance between an engineering decision and a business decision.
Yes. No, I definitely agree. And I don't think anybody could be this ideal systems engineer. But what I want to do is bring it out because I think there's a lot of subtleties and a lot of pieces that were really critical when I looked at, so actually let's go to the next slide here. So when I visited, Skybox, I visited Planet Labs, and it's interesting because, all these different places have different cultures, and, that culture and that idea of, and I'm a systems engineer, so that's where I really resonate and I really pay attention to. But really this slide is meant to say, what is the right solution? Or is, and as I've been arguing here, or is the better question, what is the right culture? After having going through the markets, studied what different businesses want, I honestly don't know if I could sit up here and actually say that a Dove is better than a Worldview, or Skybox or Landsat are better. They're all approaching similar. These are all similar missions. They're all approaching it differently, and they're doing different jobs with it. And I think it's and actually I think the struggle between the two is going to be very helpful for very helpful, or for the entire industry as a whole to really say what did we go too far on our risk aversion in the large satellites, and have we gone too small with a CubeSat on the other side of the equation.
Can I ask a question on this here? Actually, I think it bears on what you're talking about right now.
Yeah.
And that is that I don't know if you're asking the right question, because it really depends on how much one-shot risk you have. In other words, Worldview with their larger satellite, 2.8 metric tons.
Yeah.
It seems they've got a lot more invested on each and every launch than
Mhm.
Dove does at a 5 kilograms per satellite.
Yep.
So the engineering that you apply to the Worldview has to be much more precise and rigorous than Dove has to do. And so they can be more loosey-goosey and maybe we'll try this, maybe we'll try that tomorrow, and
Yeah.
they don't have to write anything down. Quite the opposite for Worldview. So the culture is really depending on how much exposure to risk you have for each solution you arrive at.
Yeah.
I agree. And I also am looking at the bottom line. 0.3 meter resolution versus 3 meter.
Yep, order of magnitude difference.
It's the mission you are trying to accomplish sort of dictates, at least on an individual satellite basis at this point,
Mhm.
what it takes. And that
But
just
I,
runs into that risk reward unless
Yeah.
you can combine all the Dove data and bring down the resolution.
and I think in one way of thinking, I think that's correct. On the other side, I would challenge you. Yeah, I would challenge to say, could you make a 30 centimeter resolution satellite, at more the cost scale of a Dove or a Skybox?
That's a good question.
Yeah, what are the assumptions? What are it's very interesting, because what are the assumptions you just in your statement did you use to say, okay, this is the way it's gonna be? Yeah, that's why I'm saying there's no real right answer. I actually love what both of them are doing.
Your question is answered by the physics.
Yeah,
The reason
that's
that-
optical resolution and telescope.
Exactly, right, which is why, which are the requirements that drove the size of the Worldview 3. In other words, you can't get a 0.3 meter resolution out of a 4-inch telescope. It's just not going to happen. But maybe if they have a technological revolution and do a synthetic aperture in the optical domain, maybe yes, you can. And that would then be that would literally be a paradigm shift, similar to going from vacuum tubes to semiconductors.
Yep.
So their costs would dramatically plummet, and so their risk exposure is still at the Dove level, but they're producing results
Yep.
at the Worldview 3 will make Worldview 3 go out of business with that model. So if you have that solution, in other words, the revolutionary technological solution, you are in a very good position. And so I think the systems engineering goes back to the risk that you have on a per satellite basis.
I mean, I completely agree with all the points you guys have made. I think that there's a lot of great things in this slide. One thing that you can add to it is to say what's the right solution or what's the right culture for this customer, right? That customer is going to determine the mission, which will in turn, determine the specs, the risks, the costs for your whole business. So it's kind of a holistic approach. And not everybody's going to say who all their customers are, and I think that it's always a question of what those priorities are, I guess. And this is obviously stuff that you're already thinking about.
No, yeah, those are actually good points. I actually added this slide about half an hour before the meeting here today. Cool.
It really highlights the factors, the relevant factors having to do with the culture that is chosen.
Yeah, the picture I actually stole from, out at Stanford, they had a talk about investing in new space technology as part of an MIT alumni group, and that's where I got the picture from. It was a former Space Angels investor who made this one.
And regarding the resolution, I don't know if any company is working on this right now, but if you can do the maneuver to get a couple of your small sats in the right position, then with software you can greatly increase that resolution. But it sounds like it'd be tricky to do. And then also, I think it was you that mentioned, I'm not sure if it was you, but how the trend of the small sats is going to go from being really small towards getting bigger in size as all these things continue to be cheaper. So as launches continue to be, price is going down there, all the component costs are going down, then you'll be able to start scaling up again. So I forget who gave that analogy, but it was a good one.
Now, we're already seeing that to a certain extent with some of the, for example, the lunar mission using a 6U CubeSat rather than a 3U. You know, I've seen a lot of mission designs lately for 6U CubeSats, which we haven't seen until recently.
Yeah.
And to some extent, the largest size of the satellite is related to the price of the booster that you can put it on. And so if you can't launch a 10-ton satellite, then you don't build a 10-ton satellite. It doesn't make any sense to do that. But if you can, getting back to the systems engineering, I guess we should.
No, that's okay. That's okay. This is good conversation. So really, this slide, we don't have to go through this, but this is something that as I started to think about these in my last company and really the experiences I was seeing at a traditional aerospace versus going to visit these other new space companies, I started having these thoughts in my head. And I don't know if you guys have seen this before. It's a white space analysis, where you take basically two axes and you say, cost versus capability, or customer needs versus the capabilities that you're supplying, and you just build 20 of these, and you start plotting where does cost versus capability. So if you look at we'll just say some government satellites, probably at the very far right top hand corner, but then we go down to a university CubeSats at the very far left hand corner of this. And it's really interesting. And what I was doing in my head was actually starting to place all these different dots on this, and I started saying, there's a lot at the extremes. And this idea of mine started to come up. This is actually the idea my company is based on, is called what I call middle space. I think I was watching Lord of the Rings at the time, and when I came up with this, but basically middle space. And what I was thinking about this is, how do I leverage the agility of these new space companies? They're able to accommodate the new ideas, like we were hearing with this conversation just a minute ago about, can you do a 30-centimeter resolution satellite? And so these new space companies are really able to start leveraging these new ideas, trying them out, moving them, and they have that agility. But the customer base, as you talk to the customer base, really has that need for reliability, rigor, mission quality. That is, that comfort level they had with the traditional satellite programs. And this is really where I started thinking, how could I create a company that really addressed this middle space? There's this big gap in between very expensive satellites and very cheap satellites. I think there's a couple players. I think Surrey actually lives in this middle space realm to an extent. There's probably a few others that live in that realm, but it's not many.
Two questions. When you say reliable, are you talking on a per satellite basis or on a per mission or product basis, which leads into system? Is the system requiring multiple small sats to combine imagery to reduce resolution, or is the system a worldview 3 kind of approach? So those two things, it seems to me, are sort of the crux.
To a space community, yes. To my customers, they don't care.
Wait, if I'm a customer and I need that view of whatever it is that I'm supposed to be looking at, and I need it on a daily basis, and then you come back to me that, well, maybe I can get it to you on a daily basis, but I'm sure you don't mind if I don't, right?
No, the point is really, the customers really don't care. Is it a constellation? Is it a single big satellite?
Okay.
Is it an airplane?
They just want the mission.
They really don't care.
They want the result.
And as someone who loves space, that sometimes is really hard to get over that hurdle of you don't care about my beautiful space system that I've created in the back here. But yeah, no, I think to your question there, it's really whatever whatever solves the mission that the customer is looking for
Okay, so
is
it's
okay.
mission driven.
Yeah, it's mission driven, and I think that's one of the really key, and that's really one of the key things with Middlespace. If it wasn't, to me, if I was a traditional aerospace company, I would say this is my heritage. This is the way I would do this satellite. In most cases, it's very hard to propose something that's not, a heritage type satellite.
No, if you go to Lockmart,
Yeah.
we build these things,
Yeah.
buy one of them and go someplace else.
Yep.
So,
No, and I think it's really interesting because the customer, to them, probably there's probably some new space, new idea approach that's at the system level is the best way. But then how do you back in and balance that with the risks that you were talking about? What's the risk to get there, spending an investor's money, and how do you get the information reliable?
Before you move on,
Yeah.
actually, and don't take the time if you don't really have it or want to, but
Yeah.
if you could maybe walk us through this mission statement or whatever
Yeah.
this guiding principle.
Yeah, this is really
maybe,
yeah.
'cause
This
it
is our.
seems like I imagine you put a lot of thought into these few words, and they.
Yeah, we put some thought. I would not describe it as a lot of thought. I would say this is an idea that's been brewing for over a year in my head.
Mhm.
Middle space is described. So when I say it's described as leveraging the agility of commercial new space technologies. So this is that idea that I was saying. I was all the time, and I would get these proposals from customers when I was at SSL. And there'd be these new technologies that could really make a breakthrough in that delivering that piece of information to that customer. And I was a new business, so I really wanted to win a business. And so if I could make it cheaper, that was a great way to go. But so this is where the reliability and rigor of mission quality piece of it comes in. Is even the customers, a lot of these customers, their business relies on this system working. And if you have a new system that goes up and you tell a customer, even in a new space environment, you're spending tens of millions of dollars, and you tell this customer, you spent tens of millions of dollars, there's an 80% chance that it's going to work. And especially when you talk to commercial companies, that could very well sink a commercial company. And so that customer has to step back and really, I was trying to address them. They had to step back and they had to say, do I go with something I'm really sure is going to work, especially if it was a company that had their first satellite going up, or do I take the risk for the bigger reward? And I actually say I saw both. I saw customers go both ways on that decision. So and that's really so really what so the last part about it was if we could mix the best worlds of both of these, you would get a really efficient system, but it would have the reliability that's required. And I used required, not necessarily what is desired, because everyone desires quality out to the nth nine. But I think there's some sort of point there of how much do you spend versus how much do you go in. And this opens up an interesting market, I think. It allows folks who are playing at the top end of the market to start thinking about, can I move some of my portfolio down into these lower cost options and expand my business into to customers who haven't been able to afford it before. The opposite is true, and you can definitely see this with SpaceX. And I actually think SpaceX and Boeing 702 SP really showed this, is that by driving down the cost of the launch and combined with electric propulsion, you are able to take and bring the capital required for somebody to do a traditional, one of these commercial communication satellites, down to where there's a whole new set of customers who can enter the market. And so it goes both. So it actually goes both ways. There's a capital for someone to come in, but there's also reliability for the folks who are already spending money, already have the contract vehicles in place. And that's really where I was trying to drive, was how do you see it? And then,
Did you see any new, I mean, I can understand how a company wants to, have to reduce by 25% the cost of their next communication satellite. How did you see any evidence of new entrants in the communication satellite business?
Yeah, if I can leapfrog on that, I think the 702 SP was certainly a leapfrog in terms of cost.
Yeah.
But did that drive any new entrants per se, or did that drive just down the cost for EchoStar and all the traditional buyers? They just got it cheaper.
No, I think it really did bring in new players. What happened is now it drove down the overall cost across the industry, and so now folks, especially Asian, there's a lot of Asian countries that were just on that brink of being able to afford a satellite, but weren't quite at that point. And it really brought a lot of the customers around the world back into the conversation. What it also did is even the larger incumbents, a lot of times they have satellite slots that they would like to fill, but the business case is marginal. And so what it did is actually brought in certain business cases that an established player could then fill into that orbital slot and take advantage of that slot that they had versus leaving it empty. And for you guys who aren't familiar with that lingo, basically in the GEO comm satellite world, your frequency allocation and your orbital slot in the GEO arc is everything. And not every GEO slot and frequency band is going to be a profitable situation with a current assumption. But if you can somehow bring that cost assumptions down, it makes a big difference. Cool. So hopefully I'm not losing too many of you guys here. So Ursa Space Systems. So after I started understanding that middle space idea, let's see, last November now, actually took the plunge and quit a good job and moved to New York to start I was in San Francisco, moved to New York, start a company. It was a big risk, and it was huge, especially at the time, because we had, my wife and I had just found out that we're going to have a kid, so we also had that decision of do we do this or not. But the interesting thing was, as I was talking to a lot of folks, this is really where that reliability piece came into middle space. I was working a lot with the smaller NewSpace companies and then talking to their customers to really research the markets of who they're selling to, what they're selling to. And what I was finding is there's definitely a market for what those folks are selling, but there was also this really big untapped market of folks who needed a more reliable piece of data. They had started developing algorithms, and the majority of the startups are optical systems. I think there's I counted the other day, there's over 20 optical satellite startups going forward. I'm not sure what the count is officially, but and really the problems I was seeing with customers is the typical optical coverage really only happens between 10 a.m. and about 2 p.m. There's some satellites that get a little bit outside of that range. Cloud cover is huge. We live in New York, so we appreciate cloud cover. I lived in San Francisco, and I don't think everyone appreciated. Starting in October, we pretty much don't. Over here on the East Coast, we don't see the sun until spring. And so there's a lot of things that are just missed. And then a lot of these folks these systems are blind at night. And I just started thinking about what's all the activity that's just not captured? What are the things that are missed? What are the people who want to use satellite data but can't because this particular system and the way they're doing it doesn't have the reliability to every 2 days get the image of a spot that they want on the Earth? So this is, so it's really interesting because I started doing a lot of research, and this is where we landed. It was quite a fascinating journey. I started with a grand vision of a satellite system, and over the last 7-8 months have really turned to what are the products, what are the missions I'm delivering. And to go back to before, this is that part where in a traditional aerospace company, I didn't have so much access to the end customers to really start to appreciate what that end customer wanted. It definitely gave reliability to these customers, but did not have necessarily a full appreciation of how are they using the data, why are they using it. I would say anybody thinking about starting a company, basically just spend 2-3 months doing market research, talking to every customer. I've been surprised across the board as to the things that people, the problems that these different customers have and they want to use satellite data for. It's non-obvious. I've had, one group was because they needed to rent hotel rooms before another company did in disaster management situations. So I had never expected that that's why they wanted their data and they pay good money for that.
Following up on that one, they want to know what the disaster is. They want to know what the hotel, if it's still there or not.
It was just funny. That was more just if something happens, they want to know where the different damage is happening around that area, and they wanted to understand. I'm going to have to send people there to deal with this situation. And if they don't have hotels, they're not happy. They leave us and go to the competition.
That customer, did that customer think of satellite data to help solve that problem?
Nope.
Okay, thank you.
No, they had an inkling that satellite data could be used to do it, but they didn't know what was the path to get from a satellite to a piece of information on their cell phone that told them what they were doing. And a lot of customers really haven't, I don't think have that full appreciation like us in this room. We really have that appreciation of how do you get that image we see on Google Maps every day, how did it actually get on your phone? And how did it become so accurate to know where I'm at? It's almost scary some days how accurate they are. Now, the interesting thing was I had that liberty to go talk to customers, understand the customers, but I was feeling a lot like Gru there, where at a point I didn't quite know where to go because I was an engineer, not necessarily a business person, and I needed process, some sort of, I needed some sort of process as a crutch to get the business started, to really understand where it goes. But at the same time, trying to be this new entrepreneur, I didn't want to get stuck in, a big, thick business plan that is kind of the equivalent of a traditional aerospace, thick set of requirements. One thing I would suggest that really helped me out, this is called the Business Model Canvas. You can just look up Business Model Canvas online. And this is actually a great tool because it was interesting because one investor told me everyone feels their business is complex. It's just kind of like every traditional aerospace feels their satellites are complex. But I think if you go to the other side is if you can easily and quickly explain what your business is. So for example with this, I had this set up where I had this on the wall and you only are allowed to Post-it notes in each of these different sections, and you had to describe your entire business in 15 Post-it notes, basically. And it was really good because it was like, okay, I'm starting to see this mixture of a little bit of process, but that agility of a Post-it note to be able to move it around and really understand it. I started to create this connection between there's this engineering side of it, but there's also the business side of how do you create this balance between that process versus the agility that you would see. So what do we do? I'm sure you guys are all wondering that. So what we do, sorry I didn't put the satellite up here, but to solve this problem, we're actually approaching it we're doing a low-cost synthetic aperture radar satellite design. And really, when we looked back, when we were looking at the problem, we had this idea we needed this reliability, of that data to a customer. And one of the key things when I started doing the customer discovery is I really realized that the customers weren't necessarily looking for imagery. The majority of these customers are actually looking for measurements. And so that's really where the radar started clicking for us. We said, okay, how do we start setting up a measurement system versus an imaging system? And it allowed us to really start thinking about how do we design a satellite or a platform that really allows that to happen. The second thing we started working with a lot is, us in the room, we understand radar, but I quickly realized with the customers, trying to sell radar to somebody was like trying to sell an iPhone by describing a CCD planar array to them. They really don't understand what radar is or what it does. And so this is really the other piece of the puzzle that we're working on as a company, is how do I take radar data and move it from that very sophisticated user into this platform of measurements that's easy to put into other people's systems that they can understand, they can work with in these algorithms. And so it's been really good. So now this goes to the next part, grand vision versus starting a business. Actually just added this one, go for it.
Sorry, you mind if I ask you a question about
Yeah, go for it.
Your deliverables? You made a good point about how these customers are really looking for measurements
Mm-hmm.
instead of images or
Yeah.
SAR images. Could you remark a little more specifically about what they want in terms of how, like the frequency of those measurements? Like when you're able to have persistent measurement over a region, that's very different from like every 24 hours, every 48 hours.
Yep.
For example. And I guess depending on what your technology is, in other words, like what kind of resolution you can get to, that's going to be a different class of measurements and therefore a different class of segments, customer segments you can address.
Yep.
But maybe you could just address like kind of the timing issue, because that's...
Yeah, timing is a key one. And that actually goes into a little bit of the grand vision. Because when we started this mission, we had this grand vision of, a radar satellite. You could theoretically provide real-time imagery anywhere in the world, with the right constellation. But we started stepping, you look at what it would take to accomplish that. That's a very expensive system. And so the persistence is a good question. We had to really ask a lot of customers, what is good enough persistence for them? And what we found was persistence necessarily wasn't the key issue. It was really reliability of the information. What we found is most of the customers just reliably need to get information at a certain time increment, so as to really understand what's happening, as I said before, what's happening throughout the day versus what's happening between 10 and 2. You can imagine what happens around a city is much different between 10 and 2, and the age of the people moving and doing things in that time frame is very different than what happens between 9 p.m. and 10 p.m. And so that, so those were what we started to find. It wasn't that it was the persistence, it was the reliability of getting information at, diverse time sets was really the key that we wanted to address.
Right, and it depends on which customers you're talking to, of course. I mean, for agriculture, that's certainly true, but if you're looking for like, IEDs, for example, that's a different, reliability will mean a different thing, in those contexts.
It does, but I was actually surprised that it wasn't as different as I expected it.
Mm-hmm. Cool.
It was, so that was one thing. I guess maybe, I guess some of you guys might be not familiar with radar. Actually, all these up here are radar images. So just to give you guys some little background of what radar can do, because I'm not sure everyone can do it. So synthetic aperture radar is actually, for imagery, is pretty good. So you can see here, this is a false colored imagery. So we can actually start, that image was taken at night, through the clouds. So you can see we can actually start coloring in, what's green grass versus what's brown grass. So we can really start understanding, what the terrain is we're looking at. Change detection is really cool with radar. Little changes show up really nice. Let's see, we have 3D video, surface height measurements, there's a lot of work there. Any sort of tray measurement, surface features. These have actually been really fascinating, talking to customers and then going back into a lot of the research as to what could a radar system do, and is there a link that we can make with these different customers we're working with. Yeah.
So have you done the trades between essentially revisit time and constellation size?
Yes. Yes, we've done a lot of those trades. We did a lot of those trades, and then I think the smartest thing we did was we actually decided to stop all those trades for 2 months. I told the entire team to stop all technical work for 2 months and just do nothing but let's go take what we have as a baseline and let's just go test it with the customers. So I think one of the most important thing I've learned with this is why I do this in Post-it notes, is everything on this business model canvas I learned needed to be written in such a way that it was a testable theory. I need to be able to go test each piece of this somehow and then say, was I correct or was I wrong with that particular piece of the puzzle?
Can I, using this model right here.
Yeah.
It seems to me that you're a small company, and there are already existing companies that do satellite systems integration and have tons and tons of customers that anybody who could possibly be a customer of satellite data, they are aggressively pursuing. Would it be possible for you maybe to be a faster grower, to act as a feed to these existing integrators, as opposed to trying to poach their customers and that they already have a multi-year, maybe multi-decade relationship with, and instead of trying to do everything for everybody, provide the SAR capability to these existing integrators that already have customers that they can pitch that SAR capability to, and maybe more importantly, integrate the SAR capability with what the customer requires.
So that's a really good point, and I think it's really interesting to see what just happened with Earthcast and Planet Labs. Both of them have bought, actually in the last 2 months, have bought established commercial imaging companies, with that need for the customer, that established customer base, and for that established history of imagery around the world. So, and yeah, I think that's a very good point.
How do you approach the customers, and how important do you think it is to do things like make yourself likable? I'm reading this book right now. Bill Clinton's an expert at making himself likable, right? So being a business person, regardless of the culture of the industry, the organization, it seems imperative. So I'm reading this book, How to Talk to Anyone, 92 Little Tricks for Big Success in Relationships. How important do you think the interpersonal dynamic is and making yourself appealing in your presentation style to new customers and approaching them?
It's very important. I used to think I was good at it, and now that I've started to listen to videos of myself on giving presentations like this, and I realized that there's a lot of words that I put in as I'm thinking, and that really distracts from that customer relationship, and it will take longer to get the point across than it would have otherwise. I think the nice advantage, though, about having a high-tech system is the personality is one thing, but there's also a great deal of respect for people with that have a particular pedigree or an education. Even if that person is not always the best speaker, there is a lot of respect in this particular industry. I do not think that is true when I talk to banks or folks with money. That is not always the case, but when talking to most of the customers, I think the majority of space industry would they interact with.
Meritocratic system, as opposed to oligarchic.
Yeah, so it's both answers. Now that I own a business, I have to answer to bankers and engineers and other business folks. So it's, there's a lot of different ways. And really what I found is I really rely on the team. So we have we have 5 people on our team. Julie is much better with a certain set of customers. Derek has a lot of respect from a certain set of customers. I'm younger than those folks, and so I get a respect with a different set of customers. And so there's definitely a big dynamic of what you do, and that goes into understanding you have a team, and it's not just yourself that's presenting to everybody.
So, one question about the business model canvas. When you
Yeah.
did you do multiple? I know you said you had the post-it notes and you had that workshop, but sometimes people do like multiple business canvases and then try test all those things too. I don't know.
Yeah, we actually got to a couple points, and we had this grand vision of what we were going to do with this big constellation. And we got to a couple points, and we had some questions about people saying, well, do you need a big constellation? I remember one day we did 5 of these. 5 different scenarios worth of this business canvas, all lined up to each other. It was really interesting because as you kept doing, you did a different one with a different key assumption changed in it. How does that business change? It was a good learning experience. I also make our entire team every 1 to 2 months, just take a day off from doing work, and we just sit around for a couple hours and re-go through this and say, did something change from the last time we put this together? Was it the same? The nice thing here is after doing this now for so many months, it's starting to really solidify into. We don't change many assumptions as we go from each iteration now. In the beginning, we changed a lot of assumptions.
Yeah, and you touched on that. Asking questions, that's another good principle that you'll see in the lean startup and stuff, is asking why are we doing this? And then, why are we doing it at that level? And then you go up a couple levels and you discover things.
Yeah.
Question about the algorithms. So you said you have a team of 5.
Yep.
So you're engineering a satellite. Are you using out-of-the-box algorithms, or are you guys all developing custom algorithms for all these different things here? Or?
No, all this stuff really exists. We're just, our key is really we're just looking at how to take these algorithms exist and basically translate them for other groups.
Mm-hmm.
That's really what we're doing.
So just tweaking.
Yeah, a little bit.
Cool.
I think that's about it. So, and I started to go through this. I think one of the key things I've learned with this is there's the grand vision. So when I was going bananas as that little minion, versus started in business. And it's really been interesting. I came up with this idea of middle space. I quickly moved really, into a very much a traditional or a new space culture. And I'm finding as I'm developing the business and having to make those decisions, we're really moving to the original philosophy I had of middle space. And that's why I put up that example of Planet Labs earlier, because I actually think Planet Labs, Skybox, these companies, the ones that have succeeded have definitely started to move from a true new space perspective as we defined in the beginning to more of this middle space where there's some nice balance of some rigor versus that agility and creativity that's involved. And that was a big thing. And then we had, just so you guys can see, this is our team here. It's pretty, we've been pretty lucky to have such an experienced team. Other than our intern, I'm actually the youngest one on our team in terms of experience. Evan's been building radars for 30 years. Julie's been doing software security and big data work for 30 years. Derek, 20 years of engineering design, mostly subsystem work. So yeah, it's been really great. And then Hallie's actually a program manager of Cornell's current student satellite program. So it's super lucky to have her working with us. And we're located in Ithaca, New York. It's about a 3.5-hour bus ride this morning down to the city, but close, not that far away, right next to Cornell University.
I think it's interesting you didn't, there's no titles there on your team. That's their background information there, but not their title.
Because they change by the day.
What?
They change by the day. So in general, Derek does a lot of the satellite work, but remember how I told you I told the entire team to just stop playing with space and technical? I gave him a new title. I gave him VP of Agriculture Marketing. And same, Julie got VP of Business Intelligence. And really, I think in a small company like this, everyone has to really work together, really wear a lot of hats. I mean, I think yesterday I was IT, CFO, CEO to sign off something. So and I did, and I wrote this presentation, and I actually think I did some technical work yesterday too. I think I did a couple of equations. But no, really, you just can't be one particular discipline or the other. You really have to do a lot of them. And
Where are you guys based?
Ithaca, New York.
Oh, in Ithaca.
Yeah, we're in Ithaca, New York, so right next to Cornell University. So about 3.5 hours north of here. Yeah, it's nice. I like Ithaca, and then it's actually there's a lot of talent around the area in terms of engineering for what we want to do.
Plus, it's gorgeous.
Yes, gorgeous.
You know about gorgeous?
Yes, I know about gorgeous.
Student suicides.
No, none of that.
Are you tapping into the student community there?
Oh yeah, definitely. Huge interest from the student community, so they'll come and do a lot of work for us. We also have a lot of professors very interested in what we're doing because it's out there, it's new. They don't often get that next to them there in Ithaca.
Is that why you moved to New York, or?
Yeah, I actually decided to move the company to New York. I originally founded the company in San Francisco, and there's a lot of competition and a lot of cost to live and stay in San Francisco. And was looking around the country for different places to move to, and just found that the talent in Ithaca was very, very good. And partially had to do with Mason Peck. He was the former NASA CTO a couple years ago, and he really put the hard sell on me to move to Ithaca, New York, so that he'd have a space company in Ithaca to have fun with. Yeah. And then, I know it's a lot of words up here, but we've been working actually since the pitch competition with the NewSpace New York City folks here, and we actually decided to look at marketing and how we brand and how we think about the business. And I just put up, this is actually our rough draft of what our overall mission statement of the company is going to be. I can let you guys read it. I think the big thing with this is really fascinating to me. There's only one sentence in here about anything to do with space. If you look at it, everything up at the beginning, we started out with how do you understand the world? What do we provide? So we're providing that location-based services, and we're providing it accurately and reliable. So we really found that the reliable was it. It was very useful. And then we're saying we are high tech, and we use some interesting algorithms. And it's interesting, how do you actually phrase that? You phrase it about a farmer, about a cartographer, versus about an analyst in a field, getting this information. But that's where I'm at. Thank you guys for participating in the feedback. This is my first time actually trying this idea of the culture and the art of systems engineering versus necessarily just the process of systems engineering. And thank you very much, and we'll see how it goes. If you have any questions, let me know.
Have you nailed down your resolution that you're trying to achieve in your first satellite?
Yes.
Okay. And when do you think you'll have that satellite ready to launch?
We're looking to have that satellite ready to launch in a couple years. So we're working right now. We're actually working with a couple of organizations right now to nail down what the exact launch date will be. So hopefully in a couple months we'll announce when that launch is going to come.
Who's building your satellite?
Kind of we are. I would say kind of we are. We're taking
Planet Labs in the garage?
No. We're trying again to go into that middle space approach. I'm trying. We're in that process right now, really trying to figure out: do we go all the way vertical, like a SpaceX, like a Planet Labs, or on the other side of the spectrum, do we sub it out to somebody, or I'm really interested in is if there's actually something in the middle between fully vertical versus fully subbing out the components.
How big is the satellite going to be? Don't you know that yet?
They won't be CubeSats, but they won't be monster satellites.
Small satellites.
Yeah, they'll be small satellites. Yeah.
Like a 6U or something like that, or larger than that?
They'll be small satellites.
Do you know who's going to launch them for you, or is?
Whoever has the right price. really, honestly, in the launch side of it, it's I actually don't think launch is going to be a problem anymore. I've found more supply of launch than I think there is a supply of satellites to fill those launches right now. There's so many new startups coming in, on the launch side. There's a lot of, both on building new rockets, but also on how do you better utilize the rockets that are available.
How'd you come up with the Ursa, the title, company name?
Yes. So the company, actually, the initial name of the company was NewSpace. But
That's taken already.
Your wife nixed that, or?
Kind of, actually. She didn't, she was like, not so much. In real, what happened is the mascot for Cornell is the big red bear. And I was actually sitting eating breakfast with a book of constellations. So I was like, every space company has a good constellation as part of its name somewhere, and that's really what happened. It was over breakfast cereal looking for a name.
You didn't think Cassiopeia was snazzy sounding?
Yeah. I don't know. It just kind of stuck, and I actually found out that another startup had wanted to use this name, but I had already grabbed it, and so I had to change their name because I had already grabbed the websites and the naming. Yeah.
I'm kind of curious if you could talk a little bit about how your conversations with customers evolved. I mean, you showed the business canvas slide. And actually, the guy who came up with that whole concept came here to speak a few times.
Oh, okay, cool.
He's part of the Columbia Network. I think it's Steve Blank is his name.
Yeah, I think you're correct.
So you have these set of falsifiable hypotheses.
Yep.
Right? So like a hypothesis is these customers want to buy product X.
Mm-hmm.
Right? But you're starting with these SAR images.
Yep.
And it's kind of like, well, you don't sell some kind of tiny little functionality in your smartphone. So like, did you go to the ag guys, did you go to the whatever business it was and say, hey, we've got these SAR images, or did you kind of guess, hey, you guys want to see cars, or you guys want to see images at 2 p.m. over these lanes? I'm just curious about how that evolution went, just how that evolves.
Yeah, so there was a large evolution to it. The first part is I already knew a little bit about how people use radar imagery, so as to start the conversation out, somewhat intelligent. So the great thing with that is I had contacts who already used radar, knew what to use radar for, and that's where I started those conversations. One of the real key parts was if I was fresh out of school, I would not have known I would not have had A, contacts throughout the industry, and B, I would not have known to go start with the people who are already the experts in it. So kind of the low-hanging fruit. There was definitely a number of customers we talked to who, gave us the blank stare of, why do I want radar? Or, I had one company ask me, can your radar do this? And I had no idea. But what ended up happening is every time a customer would ask me about a problem, I'd go research, literally spend probably 3-4 hours on each of these questions, going into different publications of a researcher has done this or a researcher has done that, to see, okay, can we solve that problem or can we not solve that problem? And a lot of there are some conversations that went, no, we cannot do anything in that field. One of the fields that really surprised us was actually weather. I originally did not know I could do anything with weather, and so I dismissed a few customers who came to me and asked. I think they more just blindly asked. It's a radar. We use radar on the ground for tracking weather, storms. Can you do something? And I didn't know the answer, and I actually lost a few customers because I did not know that was there. But after a few customers asking that question, did the research, and then started to have those conversations. And I learned a little bit of how to change the conversation. The conversation is not anymore necessarily, can you use the radar, but do you want to go work with us to see if the radar can solve your problem? And that's a much different conversation, and there is a large number of companies who have an inkling that what we're providing could solve their problem, but they haven't had an opportunity or a chance to try that out. So it's I'm a little around your question, but it was an interesting evolution of how that customer interaction went.
Yeah, it makes sense because you're removing a risk from their side of the equation and say, hey, come explore what we might be able to deliver. You're not saying make a decision now whether you want to work with us as a kind of contract or whether they want to purchase something. It's kind of just inviting them a little bit more, not getting them to commit.
And that's really a key, and that was part of the key of the stepping stone. I'm a new company, I'm a 4-person company. My whole team, we may be very well respected in our fields and what we can do, but as a company, we're not a proven company. And part of the conversation, I had to realize I'm not at SSL anymore. I'm not the Goliath that everyone knows can go deliver what they say they're going to deliver. I'm this new company, and so I have to approach that problem of, are you willing to take the risk to come work with us to see if we can solve your problem?
SSL for example, has a brand to protect as well. So I mean, this is true not just in aerospace, but in any company. It's
any
you
company,
can't take those kinds of risks.
Yeah, exactly.
Do you see yourself trying to do the vertical entirely, or are you looking to purchase like part of Planetary Labs or Skybox as a wholly owned subsidiary?
We're definitely not going to be we're definitely not going to be a vertical integration. We're not going to vertically integrate, and we're not going to just sub it out to somebody else fully. Is that what your question was?
In other words, what's your exit strategy? Is it to try and become Planetary Labs, but in SAR, or is it to be purchased by Planetary Labs as the SAR part of their business?
I want to build a company. I want to build a company that sells the uses the customers are coming to me are just amazing, and I'd like to just be able to do that. What the actual exit is, if I go under Planet Labs or a larger company, or if we decide to IPO, I don't know. That's really just too far in the future and just something I don't really think too much about.
You mentioned that there are some 20 optical sat startups.
Yes.
How many SAR sat startups are there?
There's more than one.
And what about the existing competition for the spectrum?
So the interesting thing is, other than EarthCast's announcement, EarthCast is the only truly commercial one. All the other SAR systems are all public-private partnerships. So this is so having commercial radar satellites is very unique in the industry.
What about, it occurs to me now, what about the frequency allocations and how do you avoid the interference? Some people might object to being when your satellite's passing over that they lose their comms. How?
It's a different frequency band than comms.
What frequency? It's going to be known. So.
Yeah. So it's 9. Yeah. So we're an X band. So that's 9.6 gigahertz.
Okay.
Versus the communications is down in the 8 gigahertz. So it's different frequency bands.
So this is about a question about collaborating with other existing small sat image related startups.
Mm-hmm.
Without thinking too much about partnerships or acquisitions or anything of that nature, just thinking about what the customers want, the data that they want, and what the deliverables that you can gain by combining SAR data with optical-based data or other kinds of data. You can think of a lot of different things that you get, even more so than just like coverage at nighttime and over the clouds. There's lots of things you could talk about. Are there any conversations that Ursa would be open to? Or is Ursa's attitude, we're just SAR, we're only SAR, we're going to sell SAR related data? Or is it something like, well, we'll have our SAR, we're going to get that to work, and then we're going to put up optical satellites? Is there anything like these you can shed light on, or is maybe this is too far out to even address?
There's huge potential of combining the sensors. You know, there's a few programs actually NASA is pursuing right now to say, can we combine optical, hyperspectrals, IR, radar? There's and there's folks really looking at what does that combination bring together, and there's huge potential there. And we would be not very smart to at least not pay attention to what those combinations could be, and if there's a way we could eventually play into those systems.
Why X-band? I would think L-band.
Could you?
And X-band can still have communications interference.
It can. It's just for all the different, there's a whole lot of reasons, everything from product to regulations is why we're choosing what we're doing.
Can you mention altitude?
No.
Okay.
This is actually something that I believe you brought up earlier, Garrett, at an earlier meeting, which is that there would be a big demand for image encryption as you have increased volumes of image-related data getting sent down. And I'm wondering if that's a particular service that you provide, that you've got kind of covered on your side, or are you using a third party to take care of that, or is that just something you don't worry about for the kinds of customers? Encrypting your images between
security, yeah, I would just say in general, security is incredibly important. That's a really big key in order for us to go forward with any sort of SAR radar system or optical system. Is really, how do you secure your satellites? How do you secure your data? How do you bring that to the folks that are interested in what you're doing?
What do you have in mind for ground station? Get it down.
We could talk about that offline.
Okay.
This question is more of your services.
Yeah.
What is the sustainability of your services, seeing the type of customers that you're getting now? I'm guessing it's like a range of customers.
And that's actually one of the key things with radar versus optical. Optical systems, there's a number of them that you can do one survey once or a survey every so often, and it really is enough for what you're working there. So Google Earth doesn't change, the Earth does not change very fast, versus radar is really for those times when you need to see through clouds. You're a customer who needs, you're looking at more active things that happen in more real time. And so for our customer set is much more of a, looking at very active things that change, very dynamic situations. They're not, most of our customers are not very static situations.
Non-technical, actually.
Whoever.
Getting back to your ground stations again, one of the major problems is bandwidth to the ground for all these 20 different optical startups. You're going to have a similar problem. I'm wondering, isn't there maybe a business for, do you think, would you be interested in purchasing ground services from a third party to provide you with the pipe to get to your satellite around the world?
There's a lot of really interesting business plans around that right now, and I'm very interested to see where that goes.
Was the NewSpace NYC the first competition you participated in, or have you done others?
That was the first time I publicly said anything about my company. So at that event, yes. So yeah.
Are you looking to do other competitions?
Not necessarily.
Okay.
So.
Could you, I understand SAR has applications out the kazoo.
Yep.
Are you targeting a specific application first?
We're at the point right now where we opened up our aperture really wide and found what all the customers were. And our team is going through the process right now of that hard process of trying to narrow down who do we work with first, What are the first products that we're going to deliver to the customers? I don't know the answer right now, but we will hopefully know very soon. Or whenever we get our first contract, that's who we're gonna that's who we will focus on first.
And you're talking about a single satellite, not a bistatic.
There's a lot of different ideas, and that's part of that process of understanding the customers.
All right, thank you.
Do you envision yourself going for another round of funding to make some of these things happen, or are you sufficiently funded for that one first satellite, and that's your goal right now?
We're working through the funding, the way we fund it right now, and I think that's actually been a really key lesson as to what is the best way to fund a company like this. Is it VC? Is it government? Is it self-fund? Is it, are there other stepping stones to go through? I think that's a really key question I wish I had asked and thought about more earlier on in the process.
We see that you have a NASA associate on the slide there. Does that mean have you applied for SBIR?
Oh, which NASA? Oh, which?
Or former NASA.
Oh, Mason Peck. Oh no, he's professor at Cornell University now, and he was part of NASA. If there was the right program, the right opportunity that made sense with NASA, we would definitely work with NASA.
Are you guys looking at SBIRs?
We're looking at everything right now. We're just really we're looking to see what is the best path. That's why I said we have to look at our customers, and we have to look at what is the right funding, and we're in that process right now of what's the right match between all of those.
Yeah, I'm sure there's a lot of options to consider. I just know on the SBIR side that multiple agencies are putting money into small sat technologies,
Yes.
including NASA, but also others. So.
Mm-hmm. Cool.
So I'm just sort of curious. You said
Do you guys want to wrap up here, or do you? I can talk.
Last question.
Yeah.
I'm sorry.
No, that's fine.
You felt launch wasn't really a problem. Can you elaborate on that? Because
If you asked me this question a couple of years ago, my answer would have been launch is tricky to find the right rides. But since it was such a problem, there has been a lot of companies who have stepped up to solve that problem. And right now, I think there's as much of a how do we, the folks who have stepped up to try and solve these problems are trying to figure out how do they actually fill all these slots that they developed.
that implies to me you're looking at a ride as a secondary payload. Because primary payloads, I think that manifest is pretty well booked up.
Nope, not true. You should just. I would really go look. If you go look across the industry, there's a lot of folks developing new small launch vehicles. Both the government's funding some of them are being privately funded, and I think I actually was very surprised at how much availability there are and how mature some of the technologies are. I think there's going to be some critical decisions I have to make, going back to this middle space idea of, how many launches do some of these new rockets have to have before I'm comfortable betting my business on that particular rocket? Because for us, our first satellite going up, if it fails, that's probably end to the business, most likely.
Mm-hmm.
Yeah, one example is Blue Star, which they gave a talk earlier this year, and they have like a balloon rocket. No launches yet, but it's, and I'm sure there's a wave of opportunities over there. Thank you very much, Adam, and we wish you the best in your entrepreneur journey.
Thanks.